Hello and welcome to this video. In this video, we want to look at how we balance redox reactions, and specifically we'll look at how we balance them in acidic media. Look out for another video where we'll look at how we balance redox reaction in basic media. Please don't forget to subscribe to our YouTube channel, Zulua Consultants, and the Facebook page, Zulua Consultants, for this and more videos. So let's look at what you need to do to balance an equation in acidic medium. The first thing that one needs to do is to identify which compounds or which radicals are undergoing oxidation and which ones are undergoing reduction. So we'll put oxidation here, then we'll put reduction here. So which ones are undergoing oxidation? Well, when you look at the equation, the easiest way you can identify which species are undergoing oxidation, it is by looking at which compound has gained oxygen. So that's the easiest way we define oxidation, that oxidation is the gain of oxygen, while reduction is the loss of oxygen. But in more details, you can also look at how the oxidation number is increasing or reducing. That is the best way of identifying which one is oxidation and which one is reduction. So in our case, we can notice that this one, SO2, is becoming SO4 -2. Then on the reduction, we have Cl3. It is being reduced to Cl-. After you separate the reactions, the oxidation reaction and the reduction reaction, the next thing is you equalize the number of oxygens. So when you look at the oxidation reaction, on the reactant part we have 2 oxygens, while on the product part we have 4 oxygens. So what do we do to equalize? We have a difference of 2 oxygens. So that difference of 2 oxygen is equalized by introducing molecules of water. So this simply means we'll have 2 molecules of water that will give 2 oxygens. Then we'll also have the SO2 and SO4 minus there. So here we have balanced the oxygens. Let's look at the other side. When you look at the reduction reaction, we have 3 oxygens on the reactant and none or 0 oxygens on the product. So what do we do there? We'll simply introduce 3 molecules of water, 3 molecules of water on the product part. So we introduce 3 molecules of water. So this is the second step that we need to take when we are balancing in acid. So we have now balanced the number of oxygens, the number of oxygen atoms. Now you notice that we have introduced the hydrogen atoms. So the next step now is to balance the hydrogen atoms. Now how do you balance the hydrogen atoms? We balance the hydrogen atoms by introducing the ions of hydrogen. So how do we know how many ions of hydrogen should be introduced? When you look at the oxidation part, you will notice that we have 4 in total hydrogens. So this simply means that on the product we should introduce 4 ions of hydrogen. So we'll say 2H2O plus SO2 SO4. Then we'll introduce 4 hydrogen ions. So if we do this, we have balanced the number of hydrogens from both the reactant and the product. The same should be done also on the reduction reaction. So you notice that we have 6 hydrogens there, that is 3 times 2. So on the reactant part, we'll introduce 6 ions of hydrogen, then we'll add it with the reactant which we have there, then we'll also write the product there. So at this point, you can see that the number of hydrogens now have also balanced. So let's see what we need to do next. So now that we have balanced the hydrogen atoms, we have now to balance the ions. Now, how do we balance the ions? When you look at the oxidation reaction, you will notice that the reactants have a formal charge of 0, while the products have a formal charge of -2 and +4. So the difference is +2. Now, what do we do to reduce this +2 to become 0? We are simply saying we'll introduce 2 electrons on the product part. So we'll rewrite the equation. When we rewrite the equation, we are saying we now have to introduce 2 electrons so that we balance off the number of ions so that the charge of the product should also be 0. So in this case, we have balanced off the electrons. Let's look at the reduction part. On the reduction part, we have the reactants, these reactants, they have a formal charge of +5, while the products have a formal charge of -1. Now, what do you do to balance so that the formal charges are equal? So where there is a positive sign, that's where we introduce the electrons. So we will introduce then 6 electrons on where we have the positive sign so that we can have a formal charge of -1. So we are introducing 6 electrons this other side so that we have the formal charge of -1. So at this point, you will notice that even the charges have balanced. So after the charges are balanced, let's see what we need to do next as we are balancing in acidic. Now that we have reached this far in our balancing, we have the oxidation reaction there. We also have the reduction reaction. You will notice that we have one puzzle to solve, which is balancing off the number of electrons gained to the number of electrons lost. So what do we do here? To balance off the number of electrons gained to the number of electrons lost, we simply find the multiplying factor of the 2 equations. So when you look at the redox reactions, the 2 reactions that we have, for the oxidation we have 2 electrons, then for the reduction we have 6 electrons. So we simply have a multiplying factor of 3 and 1 so that we can balance the number of electrons. Now that multiplying factor affects the O equation. So what will be the new equation for oxidation? The new equation for oxidation will have 6 molecules of water, and then it will have 3 molecules of SO2, then we'll have also 3 of SO4 2 minus, then we'll have 12 hydrogen ions and 6 electrons. When you look at the reduction reaction, it is being multiplied by 1. So this simply means this reaction will remain the way it is. So we have 6 hydrogen ions there, then we have the radical there, then we have chlorine ion and 3 molecules of water. So now that we have reached this far, we simply add the 2 equations. So you add the 2 equations. When you are adding the 2 equations, some of the reactants and some of the products in the 2 equations will simplify. Take for instance, you will notice that the 6 electrons on the reactants will simplify with the 6 electrons on the product. And then the 6 hydrogen ions will simplify with these 12, remaining with 6 hydrogen ions. Then the 3 water molecules will simplify with these 6 molecules of water, then will remain with 3 molecules of water. So what is the final reaction that we have after adding? We'll have 3 molecules of water, then we'll also have 3 SO2 and ClO3 minus, and then we'll also have the Cl minus plus 3 SO4 minus 2 and 6 molecules of hydrogen. Now when you look at this equation, this is the final equation that shows the balanced equation in acidic media. Now why are we saying this is the balanced equation in acidic media? This is because we now have 6 hydrogen ions, showing that this is an acidic media. So in summary, what are the steps that are needed to balance a redox reaction in acidic media? The first one, you need to separate the equation given into oxidation and reduction. Then you balance the oxygen atoms by introducing water molecules. After you introduce the water molecules, you balance off the hydrogen by introducing hydrogen atoms. When you do that, you now balance the electrons in the oxidation and reduction reaction. Thereafter, you simplify the equation by adding the 2 equations, the oxidation and the reduction reaction. If you do so, you have managed to balance in acidic media. So look for a video which will be posted to show how we balance this very equation in basic media.